Okay, taking a look now at section 4-5, congruence in right triangles. Um, Before we get to the idea of right triangles, I think we need to go back to, we have to prove that two triangles are congruent, side, 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 angle, side, angle, 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 side. The ones that don't work, angle, 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 and again, we've been through, discussed that once or twice. And then angle, side, side. Now, the drawing that you see at the bottom here is really an illustration of why there is no angle, side, side, triangle congruence theorem. Too many things can happen, okay? With all of these, the ones that are legitimate, the ones that you've been using, if we go through given that information, there's only one shape and one size for a triangle. So no matter who draws it, if it's done accurately, you follow those same exact measurements, we're always going to get pairs of congruent triangles. For angle side side, it's a kind of a complicated relationship here between the length of the two given sides. Again, you could say the proportions there, the ratio, and also the measure of that given angle. Okay, with the first one on the far left over here, if side A is significantly shorter than side B, it won't even close up to make a triangle in the first place. Okay, if side A is a little bit longer, still shorter than B, we might get the perfect measurement here. So we get one point of intersection. There's only one location here for point B, in which case we would get congruent triangles. But if side A is just a little bit longer than what you see there in that second figure, oh, again, drawing an arc with a compass, we get two possible locations for point B. Is everybody's triangle going to be congruent when you have two correct answers, two possibilities, two choices? No. And then if A is even longer, notice, I'm sorry, let me go back and point this out. For each of these, they're keeping angle A the exact same measurement. They're keeping the length of side B the exact same length. What they're doing from one figure to the next is changing the length of side A. So here it's too short to make a triangle. Here it's the perfect length to make a triangle. Here it's a little bit longer and it makes two different triangles. And here it's longer still. And now when we make the arc, it's gotten so long that this second solution that we had here gets lost here. So we don't have an angle side side theorem because there are too many different possibilities here of what could result with that given information. Now, there is an exception here, which goes back to this particular figure here. How can we ensure that we're going to get that perfect length that'll get us just that one possible triangle? Okay. And hopefully you remember the title of the section here. There's a hint. If that given angle is a right angle, well, what happens? When any two pairs of corresponding sides are congruent, and one of the angles is a right angle, what can happen here? Well, if we have the two pairs of corresponding sides that make the right angle the included angle, then those two triangles turn out to be congruent by side angle side. And that's no big surprise there at all. Again, for side, angle, and angle, angle side, any pair of those congruent angles can be right angles. Okay. This one is where we get something interesting that happens. So we have, again, segment AC and segment AB marked congruent to segment DF and segment DE respectively. But now the right angle is not the included angle. This appears at first to be angle side side, which you're never ever ever going to use. You're never ever ever going to write that down as your response. But the fact that it's a right triangle, we have an additional restriction, the Pythagorean theorem. So if we go through and figure out the length of BC, figure out the length of EF, well, wait a minute. If you're given two sides of a right triangle, the Pythagorean theorem will help us solve for that, the length of that third side. We're going to get another pair of congruent sides. So these triangles are congruent then by the side-side-side congruence theorem. So this leads us then to our exception, that if the angle that's involved here happens to be a right angle, then angle side side actually does give us congruent triangles. This exception, again, only applies to right triangles. So we are going to give it the name hypotenuse leg theorem. Again, only a right triangle has a hypotenuse. We've used the term leg when referring to isosceles triangles, but hypotenuse only applies to right triangles. So our theorem here, if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. Okay, so here's a fifth way of proving that two triangles are congruent, but we've got to be careful. For the previous four, those apply to all kinds of triangles with all kinds of side lengths and angle measures. The hypotenuse leg theorem only applies to right triangles. Now again, I don't want to give you the impression, we're going to go through an example here in just a minute, that because it's called hypotenuse leg, that there are only two things. Side, 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 angle, side. You need three pairs of corresponding parts that are congruent. Angle, side, angle, 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 side. Always you need three pairs. For the hypotenuse leg theorem to work, we have to show that we have right triangles. We have to show that we have right angles. Okay? So the right angles, that's one pair. The hypotenuses are congruent, that's our second pair. Corresponding legs are congruent, that's our third pair. That's how we can prove something congruent by the hypotenuse leg theorem. All right, let's take a look at this example. They ask what information is needed in order to apply the hypotenuse leg theorem. Well, if we look at triangle LMN, we have segment LN marked as a length of 9. That's the hypotenuse because it's opposite from the right angle. For triangle PQR, they give us that length of segment QR is 5. Well, 5's not congruent to 9. What's going on there? It's okay, because segment QR is one of the sides that actually forms the right angle. This is not the hypotenuse, that's a leg. Okay? So what information do we need to know in order to say that these two are congruent? We need to know that segment PR, the hypotenuse of this triangle, has a length of 9. And then we need to know that segment MN, the leg over here, is 5. Now, to me, it's not 100% clear here They did not give us a triangle congruence statement to start off with here. You could make, I think, an effective argument that segment LM is 5. And then we could say that the two triangles are congruent by the hypotenuse leg theorem. Okay. All right, as promised, we're going to take a look at a proof. Okay, now we take a moment here to look at the figure. It's kind of complicated. Write a proof to show that triangle JKM is congruent to angle LKM. Okay, so we're looking at large triangles to the left and to the right. We're given two pieces of information at the start. I'm going to write this out as a two-column proof where, again, we're going to come up with true statements on the left and back them up with a legitimate reason on the right. I don't know. Let's start with the first given. That segment JL is perpendicular to segment KM. Now, I know there's another given information, but again, your proof should be in a logical sequence here. If I say that these are perpendicular to one another and then ignore that to go to the other given and maybe come back to it later, to me doesn't seem like the smartest way to proceed here. If they are perpendicular, then I could say that angle KNJ and angle KNL are right angles, sorry. The reason for that would be in statement number 1, the definition of perpendicular lines. Definition of perpendicular lines: if two lines are perpendicular, then they form right angles. Okay? So then I could say that I'm going to ignore that. Well, no, I'm sorry. Let's go to that second given. Segment JK is congruent to segment LK. That's given. And now, again, if I'm just looking at these small right triangles at the top of my figure here, I've said that we have right angles. I've said that, again, from the other given, I have the two hypotenuses that are congruent. I can then say that segment KN is congruent to segment NK by the reflexive property of congruence. Any segment has to be congruent to itself. It's the fact that that segment is shared by these two right triangles. I can then say that triangle KNJ is congruent to triangle KNL by the hypotenuse leg theorem. Great. How does that help me? Again, keeping my eye on the fact that I'm trying to prove these big triangles left and right are congruent to one another. If I look at segment triangle JKM and triangle LKM, I can now say, because of the hypotenuse leg theorem, that angle JKM is congruent to angle LKM, because corresponding parts of congruent triangles are congruent. So I can say that this angle here is congruent to that angle there. And again, those are angles of those big triangles left and right. From the given, I have one pair of corresponding sides that are congruent. Thanks to CPCTC, I have a pair of corresponding angles that are congruent. I think I need two more steps here. I could say that segment KM is congruent to segment KM, again by the reflexive property of congruence. And that gives me my second pair of corresponding sides. So then I could say that triangle JKM is in fact congruent to triangle LKM by the angle, side angle side congruence there. Now again, it's really hard to mark on the picture that segment KM is congruent to segment KM because we have point N in the way. All right, so a moment for that to settle in. Proving that two triangles are congruent by the hypotenuse leg theorem, although the name is actually shorter. Yeah, that's just a little bit trickier than using our previous four triangle congruence theorems. We have to demonstrate that we have right angles, that we have right triangles. Um, so that's usually going to be either a 2 or maybe 3-step process there. And then again, a pair of corresponding legs that are congruent. You need to show that the hypotenuses are congruent. Then we can say that they're congruent by hypotenuse leg. And again, you need those 3 pairs of corresponding parts. For 2 triangles, they always have 6 pairs of corresponding parts. You've only used half of them. You need the right combination to say the triangles are congruent. Then you can name any unused pair of, in this case, I used a pair of angles, CPCTC. Corresponding parts of congruent triangles are congruent. For those of you that hesitated there just a moment about what CPCTC means. Again, let me emphasize for the 43rd time, you can only say that those parts are congruent to one another after you've shown that you have congruent triangles. You can't start with CPCTC. All right, well, I hope that gets you going here for section 5. Now, I don't want to leave you the impression here that, again, this is a common mistake. Avoid this pitfall. Anytime that you see some kind of figure, any problem that they throw at you here, where it's a right angle, it's automatically going to be hypotenuse leg. It's never going to be anything other than hypotenuse leg. No, I'm sorry, this is a one-way street. Okay? If you have a right triangle, then you can use hypotenuse leg. But don't think that because it's a right triangle that you can't use side angle side and angle and angle side. Okay. Now, if you're looking through and if you go online and look at the student interactive version of your textbook, once you get to the concept summary page, they will tell you these are the current triangle congruence theorems that can be used, can be applied to right triangles. And you notice from our list here that side, side, side is missing. If it's side, 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 we really don't care that it's a right triangle. Okay? Maybe we've used the fact that it's a right triangle to find a missing pair of corresponding sides, but that's going to happen rarely. If they give us the fact that it's a right angle, um, then side, side, side seems like that's kind of pointless. Why'd they tell us it was a right angle in the first place if we don't need to know that angle to prove that the two triangles are congruent? Okay, so I just wanted to clarify that. Again, if you look at this, we have 5 ways of proving that triangles are congruent. The hypotenuse leg only applies to right triangles, but the other 4 also apply to right triangles. Okay, again, get online with the Realize website and take a look at section 5, and we'll go through any questions that you have next time.